Welcome to Rodrigues classes. Today, we're diving into the fascinating world of sound.
Hello students, so today I have come up with the topic on sound. Here also we will be going to see the numericals here, and we have important numericals in the first part of sound. Here also a sum from this topic mostly comes in the board examination, and the sum numericals over here are very easy. So we will take a look at this part of this sound chapter. This part, as you see the heading, is based on reflection of sound and echoes. So you know what is an echo. A sound is produced and again that sound is reheard by us. That happens only when the sound is produced, the original sound is produced, and if reflects and come to our ears after 0.1 second, we are able to hear that sound again, which is called as an echo. So we'll be seeing basically the numerical based on echoes here. But before beginning with these numericals, let us take a look at which all formulas we will require here. Okay, so starting with the first one, you know sound is a wave. So as a result, the wave formula which we have will be used here. V is equals to F lambda. V here is the wave speed, the speed at which the wave is traveling. Unit as it is speed will be meter per second. F stands for the frequency of the wave, that is the number of vibrations produced in 1 second. SI unit of that is hertz, and then we have lambda, which is the length of a wave. In case of a transverse wave, you know length of a wave is taken as the distance between two consecutive crests or two consecutive trough. And if it is a longitudinal wave, then it is the distance between two consecutive compressions or two consecutive rarefactions. So this is a length, so the SI unit of that is meter. So you should know these SI units so that you can convert to the required unit and then only solve the numerical. So first formula, V equals to F lambda. If I go to the second one, frequency and time period are related. So F is equals to 1 by time period. What is time period? Time period is the time taken to complete one vibration or the time taken to cover the length of one wavelength. So you get F is equals to 1 by time period. Okay. If I use this one and substitute it here, remember if F is equals to 1 by T, I can also take T is equals to 1 by F. Okay. Now, if I take here and put for F 1 by T, I will get it as lambda by T. If the required things are given, you can find any one of them by this formula also directly, or you can apply them separately also and find. So these three are where we are relating the sound as a wave, and we are getting this relationship. Then the most important part coming here is about echoes. So in echoes, you know that if a sound is produced, again it is reheard. So the sound has to travel from where it is produced to the reflector and then come back. Usually the place from where the sound is produced, if we take there only the observer is there. So if I take, this is the part from where the sound is produced and this is our reflector. Okay, if this is our reflector, then the sound has to travel first from here till here and then it is to reflect and come back. So if this is the distance D taken, it has to travel a total distance of double of that. So the distance the sound has to travel become 2D. And the time which we will, after which we hear the echo, is the time for which it traveled. We know speed is equals to distance by time. So using that only, we get a formula here where V is the speed of that wave, which is the speed at which the sound is traveling. Now the distance here is 2D. So D is here, remember, distance from where the sound is produced to the reflector. Okay, so going and coming it becomes 2D. So we have written the 2D and divided by the time. So remember, this is the time which is when the actual sound was produced to the time when the sound was heard. So this formula will help us in all the echo sum. we can change and get time is equals to 2d by v, or d is equals to 2 vt by 2, but we will remember this and work out with this numerical only the sums. So now next we move on to is the numerical of this part, which is of exercise 7a. So let us come to the numericals of exercise 7a and let us start with the first one. The wavelength of waves produced on a surface of water is 20 centimeters. So wavelength is given to us 20 centimeter. It is not an SI unit, so we will have to convert it. If the wave velocity is 24 meter per second, so velocity of the wave V is given to you as 24. We have to find the number of waves produced in 1 second. Okay, so that is number of waves produced in 1 second is frequency. You have to find the frequency and the time in which one wave is produced. So what is the time taken to produce one wave? We have to find here. Okay, so starting with writing this number 1. So first of all, we will write this 20 centimeter, which is lambda is 20 centimeter. So 20 by 100, that is equals to 1 by 5 meter. Okay, so I know the wavelength. Now V is given to us as 24 meter per second. So let us go to find now the frequency. V is equals to F lambda. So V is 24 equals to F we have to find, and lambda is 1 by 5. So this will come and multiply here. So we will be getting 24 into 5, that is equals to 120. Unit of frequency is hertz. So we have got the answer for the first part is done here. We have seen the first one. Let us come to the second one part of it, the time in which one wave is produced. The time for one wave is called as time period. So if I go to right here for the second part, time period is equals to 1 by frequency. So 1 by 120. So a long division has to be done. Okay, this will give you on dividing 0.008 and 333 will keep on coming. So writing that in scientific notation, the decimal has to come between 8 and 3. So it will be 8.3 into 10 to the power minus 3. Time period has a unit of seconds. So we get the time period as 8.3 into 10 to the power minus 3 second. Hope this numerical is clear. A very direct, simple formula sum was there. Let's see numerical 2 here. Calculate the minimum distance in air required between the source of sound and the obstacle to hear an echo. Speed of sound in air here is given as 350 meter per second. So in this, if you take a look at the numerical data, you have only one numerical data, speed, 350 meter per second. Nothing else is there. But if your theory part is correct, you know that the time required for an echo to be heard is 0.1 second. So with your concept of your chapter, the data is known to you. So here in this numerical, the time to you is given as 0.1 second and the speed is given to you as 350 meter per second, and you are asked to find the distance between the source of sound and the echo to be heard. Okay, that is the distance between the source and the obstacle which is there. We have to find that. So we use the formula V is equals to 2d by t. For V, we go to write 350 is equals to 2 into this distance we have to find, and the time is given as 0.1. So the distance comes as 350 into 0.1 divided by 2. So 350 and 0.1, removing the decimal, the 0 will get removed. So 35 by 2 divided, you get it as 17.5 meters. So your answer here, that is the distance between the source of sound and the obstacle, okay, has to be there 17.5 meter for that echo to be heard. So we come to numerical number 3, which is a very much similar sound, but the medium is changing here. what should be the minimum distance between the source and the reflector in water so that the echo is heard distinctly, and the speed of sound in water is given as 1400 meter per second. So similar to the previous sum, only thing is that the medium is here water. So we proceed to work it out in the same way. We write here first time is 0.1 second and V is here 1400 meter per second. So we write the formula V is equals to 2D by T. So 1400, 2 into distance we have to calculate. Time is 0.1. So D is equals to 1400 into 0.1 divided by 2. That decimal with 0.1 will get removed and I will remove 1 0. So it becomes 140 by 2. So 70 meter is the distance which has to be there for that echo to be heard in that water. So we move to number 4. A man standing 25 meter away from a wall produces a sound and receives the reflected sound. So he is producing the sound, he is only receiving it, he is listening to it. Calculate the time after which he receives the reflected sound. If the speed of sound in air is 350 meter per second, so we have to find the time, distance is given and the speed is given. Then it is asking, will the man be able to hear a distinct echo? Explain the answer. So you know the reason we can hear a distinct echo only if it reaches our ears after 0.1 second of the sound being produced. So once we know the time, that will help us in deciding whether an echo will be heard or not. So we know this distance as 25. So we start by writing the formula first. So V is given to us 350 equals to 2 into the distance is 25. So into 25 by T. So T will be equals to 2 into 25 by 350. So let us reduce it. 5 5s are 5 7s are 70, 5 14s are 7s are. So we are getting time as 1 by 7 second. If you bring it in decimal, divide and get it, you will get it as 0.142 seconds. So we have got the time that it will take for him, for that sound to come back to him is 0.142 second. Now the B part, this was our A part. B part is asking, will the man be able to hear that echo or not? Look at the time, it is 0.142 seconds, so which is greater than 0.1 second. So he will be able to hear that echo. So first we will write that part yes. Reason is because the time taken is greater than 0.1 second. Okay, so you have understood this sum. So we come to numerical number 5 now. Okay, a radar sends a signal with a speed of 3 into 10 to the power 8 meter per second. So this is the speed given to us to an aeroplane at a distance 300 kilometer from it. So this distance 300 kilometer needs to be changed to meter. After how much time is the signal received back after reflection from the aeroplane? So you need to find the time after which it is received back again. So going by the formula and writing it. So V is equals to 2D by T. So V value is 3 into 10 to the power 8, 2 into 300 kilometers. So let us convert it into meter by multiplying with 1000 divided by the time. So now time will come here, this will go there. So T is equals to 2 into 300 into 1000 by 3 into 10 to the power 8. So first of all, I am cancelling this part and writing 100. So 2 into 100 and 1000 becomes 5 zeros, and here it is 10 to the power 8. So 5 minus 8 will give me -3. So 2 into 10 to the power -3, we are finding time. So the unit comes as second. So it will take 2 into 10 to the power minus 3 seconds only for that signal from the radar to reach the aeroplane, reflect it and come back. So let's come to question number 6 now. A man standing 48-meter away from a wall fires a gun. So he is 48-meter away from a wall. So wall will be the place from where reflection will take place. So the distance between the man and the wall is 48-meter. Calculate the time after which an echo is heard. So we have to find the time, and the speed of sound in air at that time is given as 320 meter per second. So same formula, V is equals to 2D by T. So V is given to us as 320. 2 into the distance is given as 48, and then by time, which we have to find. So time will be equals to 2 into 48 by 320. If I cancel with 2 first, I get 160. You know 16 3 is 48. So 16 3 48, 16 10 3 divided by 10 is 0.3. So 0.3 second is the time after which he will be able to hear that echo. So again, another numerical directly to the same formula. Coming to question number 7, a ship on the surface of water sends a signals and receives it back from a submarine inside water after 4 seconds. The ship is there on the surface, submarine is below, send the signals, it will hit the submarine and come back, and the time taken is 4 seconds. Calculate the distance of the submarine from the ship. So we have to find the distance from the ship to the submarine, and the speed of sound in water is given here as 1450 meter per second. So same formula to be used, substitute the values and calculate it correctly. So V is given to us 1450. 2 into distance we have to calculate, and the time given is 4 seconds. So written here 4, I find here this can be reduced. So this 2 will go and multiply 2 into 1450. So you multiply, you will get it as 2900 meter. So the distance between the ship and the submarine is 2900 meter, which if you want to find in kilometer will be 2.9 kilometer. So next one, 8th one, follow the question properly. Little bit part has to be understood nicely here. A pendulum has a frequency of 5 vibrations per second. So frequency is given, it is vibrating 5 times in 1 second. An observer starts the pendulum and fires a gun simultaneously. So pendulum is started and a gun is fired at the same time. He hears echo from the cliff after 8 vibrations of the pendulum. When it has done 8 vibrations, then the echo is heard. So you are not given the time here directly. You will have to calculate the time for 8 vibrations. That will be the time that echo has taken, the sound has taken to travel from when it was produced, reflecting and coming back. So time has to be calculated. If the velocity of the sound in air is 340 meter per second, velocity given, find the distance between the cliff and the observer. So only difference in this sum for you is you should know how to calculate the time when something like this is given in terms of the frequency. So we know frequency is the number of vibrations in 1 second. So it is vibrating 5 times in 1 second. So I will write like this: time taken for 5 vibrations, that is equals to 1 second. Now I need to know the time taken for 8 vibrations. Okay, for 8 vibration means how much time it has taken for 8 vibration. Why for 8? Because the echo is heard after that 8 vibrations. So you know for 5 vibration it is 1 by 5. So for 1 vibration it will become 1 by 5. For 5 vibration 1 second. So for 1 vibrations 1 by 5, and for 8 vibration into 8. So I will get here 8 by 5 seconds. Okay. Now I know the time I know the speed, so we have to find the distance. So we write here v equals to 2d by t. So v is given to us 340. 2 into d we have to calculate. Time we have got 8 by 5. So 8 in the denominator, that by 5 will come to the numerator. So now I get d is equals to 340 into 8 by 2 into 5. You know that 2 and 5 will become 10. So I am cancelling this 0 with this. So I have to multiply 8 fours is 32, 3 carry, 8 threes are 24 and 3 is 27. So the distance I have got it as 272 meter. So keep in mind how to calculate the time when informations are given in this way. Slowly the numericals are going towards the tougher side. More understanding is required, but the formula is that same. V is equals to 2d by t. Follow this question. A person standing between two vertical cliffs produces a sound. So person is standing between two cliffs. So if the person is here, one cliff is on this side, the other is on this side. Two successive echoes are heard at 4 seconds and 6 seconds. So when he makes a sound, he is able to hear two echo, first after 4 seconds, the second after 6 seconds. It means he is not exactly in the middle, he is closer to one of the cliff and far away from the other. So from the closer one, echo is heard at 4 seconds, and from the far away, the reflected sound is heard after 6 seconds. So calculate the distance between the cliff, and the speed of sound in air is given to us as 320 meter per second. So let us see with the diagram part. This is my first cliff and this is my second cliff. The person is not exactly in the middle, so I am taking the person to be here. Okay, so this is the person, I am naming it as P. So the distance from the first cliff I am taking as D1. For this, the sound is heard, echo is heard after 4 seconds, and this one I am taking it as D2, which is heard, this sound is heard, the echo is heard from here after 6 seconds. So D1 and D2 taken, we will find both the distance and we will be able to add them and get the distance between the two cliffs. So the formula used will be this only, V is equals to 2D by T. So V is given as 320 equals to 2 into that distance I have taken as D1. So D1, and the time is 4 seconds. So I will get here D1 is equals to 320 into 4 by 2. So this is cancelling here. I will get this one as 640 meter. Okay. Now let us come to the part, the second cliff. So same formula to be used. Again, if I write the formula and then substitute the values, 322 into this one I have taken as D2 and the time is 6 seconds. So D2 I will get it as 320 into 6 by 2. So this is cancelled, and if I multiply, I am going to get here 960 meter. So both the distance I know now. So I will write here distance between the cliffs is equals to 640 plus 960. So 960 and 40 will become 1000 and another 600. So 1600 meter is my answer. The most important sum of this exercise, numerical number 10. Follow and understand the question properly. A person standing at a distance x in front of a cliff fires a gun. So there is a person A standing at a distance x from the cliff and he will be firing the gun. Okay. Another person B standing behind the person A at a distance y from the cliff. So the person B distance from the cliff is y. Here's two sounds of the fired shot. So you will hear two sounds of the fired shot. First one is after 2 seconds, second one is after 3 seconds. Okay. So what are these timing for? With the figure I will explain. So at that time get it clear. Calculate the values of x and y. Take the speed of the sound as 320 meter per second. So a diagram, very important to do this sum correctly. So first of all, this for me is the cliff. Okay, this is the cliff. This is my person A, which is told is at a distance x. From the cliff, the person A is at a distance x. Now there is a person B standing behind A. So I am taking, this is the place where the person B is there, and the distance of this person from the cliff is y. So I will take here that this is y. Now this one fires the gun. B hears two sounds, first one after 2 seconds, second one after 3 seconds. So follow what are those two sounds heard by him. This one fires, the sound will travel this direction also and in this direction. So the one he is hearing after 2 seconds is the one which has come directly. There is no case of echo here. But the next one which comes after 3 seconds, it goes, hits the cliff and come back, which is the sound of the echo. That is taking 3 seconds. So one case, there is an echo case. So we will have to apply that V is equals to 2D by T. But for the first one, there is no echo case. So directly speed equals to distance by time will be applied. Okay. So from A to B, the distance which is there, AB distance which is there, from here to here is y, from here to here is x, so it is y minus x. So I will write here speed is equals to distance by time directly. Speed given to us is 320. Distance here is AB, which is y minus x, and the time in this case is 2 seconds, the first sound heard. So you get here y minus x is equals to 640. So here we have got the first equation, y minus x equals to 640. Now to take a look at the second case where echo is happening. So from A, the sound travels till the cliff, reflection will take place, will come back to y. So the distance traveled here is x plus y. So we have already taken the total distance traveled. So we will not be applying that echo formula 2d by t, because 2d entire distance here is coming as x plus y. So we again write that formula v is equals to d by t. So for v is 320. Distance, again I say it is x here and y here. So it is x plus y, and the time taken is given to us as 3 seconds. So I get x plus y, 3 into 320 is 960, and this is my equation 2. Now I need to solve these two equations. So I will write here adding equation 1 and 2. So let us see the LHS part adding. Here it is y, and y will give us 2y, and then minus x and plus x will get cancelled. So equal to 640 and 960 will give us 1600. So y is equals to 1600 by 2. So you get y value as 800 meter. So y we are knowing now, we can make use of the second equation to get x. So using equation 2, it is x plus y is 960. So x plus 800 equals to 960. So x equals to 960 minus 800, and you get it as 160 meter. So we have got our answers. Okay, x as 160 meter and y as 800 meter is our answer. Hope you have understood how to apply those relationships. Just simply don't go for that v equal to 2d by t always. That 2d is the distance from the source being producing the sound, reflecting, and the one who is hearing it. So if they are different, you need to take what distance has been covered actually. So after a difficult sum, let us come to a much easier numerical. On sending an ultrasonic wave from a ship towards the bottom of a sea, the time interval between sending the wave and receiving it back is found to be 1.5 seconds. So the time is given to us. If the velocity of the wave in seawater is 1400 meter per second, find the depth of the sea. It means we have to find the distance. So a very direct one. So let us write the formula. V equals to 2d by t. So V is 1400. 2 into our d is we have to find, and the time is 1.5. So d will come 1400 into 1.5 by 2. This I am cancelling to 700. So from 700, if I make use of that 10, I can get rid of the decimal. So I am left with 70 into 15. This 0 written, 15 and 7 if we multiply, we get 105. So the depth of the sea is equals to 1050 meter. This is your answer. So a very direct sum. So let us see the last numerical of this sound, exercise 7a, which is a graph sums. So graph of a wave should be understood properly. Figure below shows the distance displacement graph of two waves A and B. Compare the first one, the amplitude of the two waves and the wavelength of the two waves. So you have to understand this graph first. So here in the graph, distance is there in the x-axis and displacement is there on the y-axis. Okay. This is your brown color part is your graph for wave A and the black one is for wave B. Amplitude is the maximum displacement of the wave from the mean position. So this is your amplitude. For A you can see it is going up to 10. So 10 centimeter, okay, because written in centimeter. So 10 centimeter is the wavelength of the first graph A, and the second wave is going, maximum distance is here, which is coming to 5 centimeter. Then about the wavelength, take a look at the first wave, ends over here. So it is at 8. So this wavelength is 8 centimeter. For the second one, take a look, it is going to 16. So the wavelength is 16. So we know the values of amplitude and the wavelength for both of them, and it is told to us to compare, means the result should be in ratio. So let us take the first part of it first. So which is the amplitude. So I will write here amplitude of A is to amplitude of B. So amplitude of A is 10 centimeter, 10 written, is 2. For the second one is 5, unit not written because we are finding ratio. So 10 and 5 both can be divided with 5 and you get the ratio as 2:1. Then for the second part of it, we have for the wavelength. So I will write here lambda A is to lambda B, means wavelength of A is to wavelength B. Again take a look of wavelength A. So it is coming till 8. So this is 8 centimeter, and for the B part it is coming to here in the B part to 16 centimeter. So you reduce it by 8 both of them and you get it as 1:2. So you have got the ratio. This is done. With this we complete the numericals of exercise 7a. Thanks for watching the video, but do remember to like the video and subscribe to my channel, and also share it with others. That will be a good thing, that when you share it with others, also others will also get helped by all the numericals which I am doing. Once again, thank you.